So when we think of the unit circle, we could think of a point, any point on the unit circle, and we called it x, y. You know, we talk about a point as x and y. But just think about it. Really, x, if I have my triangle here, this is x, and this is y, and this is r. And I think about x over r is cosine whatever my theta is. But remember, on the unit circle, r is 1, which means that x is really cosine theta. And similarly, y is sine. So really, the points on my unit circle, so that r is 1, are cosine theta, sine theta. And we use that information when we had the unit circle where we can identify any of the values cosine theta and sine theta from what we know around here for the angles that we found, special angles, pi over 4, pi over 3, and pi over 6. Now, I can use the relationships of trig functions to find information about any point on a circle. I can just take a point here. Let's say it's I could say the point is I don't know, -3/4 and 1/2, if that actually fit to the unit circle. But if I had that point, I could find everything on it. But it has to be a point that actually sits on the unit circle. I could find all my information. But I can look at any. So this is probably not a valid point because it doesn't add up to 1 when I add them. But I could have a point on any circle. So if I have a circle that's not a unit circle, anywhere on the circle, if I had a point here, and let's say it was -5, 3 on some circle, I don't know what the r is, I could find out all my information. Here's my theta, here's my right angle, I have an x and a y, and I know that my x is negative and my y is positive. And so I know that I can find r, 5 squared plus 3 squared, which is 25 and 9. So r is 34, so r is the square root of 34. And now I can find all my trig functions because I know my relationship, because the relationship's always the same. X squared plus y squared is r squared. And also, remember we talked about before with reference angles that we can find the terminal side of any angle, even if it's more than one revolution. And we can find the information about it because we know that they're always equivalent. Every time it's a revolution, you can just, as long as they have the same terminal side, the angles are the same. They have the same values. So if I want to look at an example just to see what I have here, I have a point 5, -2. It's on the circle. It's also on the terminal side of an angle in standard position. So what I want to find is I want to find the 6 trig functions. So what I'm going to do is I'm going to draw a triangle. And actually it's in this is 5, this distance, this point is 5, -12. So this distance here is 12, or -12, and this distance here is 5. So I can say I need to find here first, so that's 5 squared plus 12 squared is c squared, or 25 plus 144, which is 169, which means c is 13. So now I have 5, 12, and 13. But I know that this 12 is a negative. So I know now cosine of my angle, because here's my angle right here, cosine of my angle is adjacent. Oh, sorry, my angle is right here. Cosine is adjacent 5 over hypotenuse 13, and sine of theta is opposite, which is -12 over 13, right? And then tangent is opposite over adjacent. And then I can find my other ones very easily by doing the reciprocals. So it's easy to find it. The best thing to do is just draw your triangle, and you're going to have to draw it there. You just draw some triangle. You know your theta. You know the x part is 5, the y part is 12, but that's negative. You find your hypotenuse 13, and then you can find all your stuff. You just need to make all your trig functions. You just need to make sure that you know what's negative and what's positive.